This is the familiar circuit called a Wheatstone bridge, and it's generally used to find the value of an unknown resistor using a variable resistor by balancing the bridge. And here we're trying to find the Thevenin equivalent circuit. So there's a six-point procedure to find the Thevenin equivalent circuit. The first thing is to remove the load. Now the load is already removed. Now usually it isn't actually a load, it's a galvanometer, but here AB is already open. And we're asked to find the Thevenin voltage between these 2 points. So really, to find VAB, you would want to subtract VB from VA. So if we assume that this lower point is our earth, then we can find VA here, the voltage across this resistor. That means the potential from here to earth, simply by using a potential divider, because these two resistors are in series. So when you do a potential divider, you can ignore the second arm of the bridge and simply say VA is a potential divider of 9 volts across these two resistances. So we can say that VA is that there. And then we can do the exact same for VB. So we can ignore everything on this side of the bridge and say VB is the potential across this resistance here. And it's simply 9 volts times 36 over the sum of those two. So that would be 4.5 volts. So that's VB. And if you subtract those two, that gives you your value for Thevenin voltage. So we're halfway through. Now we need to find the Thevenin resistance, and to do that we have to get rid of the source. So for voltage sources or independent voltage sources, we short circuit them. So here we're going to short the voltage source, and we want the resistance between A and B. Now, it isn't immediately clear, but if you look at these two resistances, you'll notice that they're connected at not 1 point, but 2 points. And when two resistances are connected at 2 points, we say they are in parallel. So even though they don't look like they're in parallel, they are. So the parallel combination of 36 and 55 will give us 21.76, and the same applies to the two 36 ohm resistances. They're connected at this point, and they're connected at the other point. So they're joined from both ends, so they're in parallel. So we can replace these two with 21.6, and we can replace these two with an 18 ohm resistor, and now we can redraw our circuit like this. We don't need these second resistors. So our circuit now looks like that, and the resistance looking through there is simply the series sum of those two, and that will give me my Thevenin resistance. Now, we found VThevenin, we found RThevenin. Now you redraw the circuit with VThevenin and RThevenin in series. Now there isn't a load, we haven't been given a load, so we can leave that open, but this is our RThevenin, and this is the value that we found for VThevenin, and this is our equivalent circuit. So this is the equivalent circuit of our Wheatstone bridge.